Hey everyone, welcome to day 7 of Math 133. Today we are going to cover the cumulative review number 1, which covers chapters 1 through 3. Not all of chapter 1, just the parts that we've done so far, but covers chapter 2, chapter 3, and we're also going to do the chapter 4 project 1. Okay. Um, so a couple things to note. Chapter 4, Project 1, we're going to work on that today, and that is due on September 23rd, which is this upcoming Tuesday, okay? Just like normal. Don't forget to do your lecture notes, 4.2 and 4.3 lecture notes. The cumulative review, we're going to start it today. It is not due Tuesday. It is due September 25th, which is a week from today. It's due on Thursday, September 25th, okay? Um, but we're going to start it today. Okay. So, so you have a little bit of time. And I actually, for day 8, I actually put a note down here. Don't forget to finish cumulative review number 1. That's for next time. Okay. Um, this is the end of week 4. So if you are watching this on the recording, you didn't get a chance to come to Zoom on Tuesday or Thursday, make sure you fill out the week 4 discussion board. And yeah, so the cumulative review we're going to work on today, you can find that on page 412, 412. Okay. Visualizer, I need to open that up. That's in your course pack, page 412 for the cumulative review. Okay. Also here in Canvas, that. So this is the cumulative review worksheet, page 412. Also in Canvas, there is a link for the cumulative review. So if you click on that, there is a link that will take you to the data sets right here, data sets for this worksheet at this link. And that's going to bring you to the list with all of the different links. You'll scroll down a bit until you get to the cumulative review. So cumulative review number 1, there is a Google Sheet. So make sure you open that. And there's also StatCrunch, which we can just open up statcrunch.com. Okay. So I don't need this. I just need statcrunch.com. Statcrunch.com, that'll bring you here. In the upper right corner, make sure you sign in. And then once you've signed in, this little orange button will light up and you can click on that. And that'll bring you to a blank spreadsheet for us to use. Okay. Um, but that's for our project. For the cumulative review, there's also data at that link. Didn't work the first time. Yeah, it's not working for me. I think it's because I'm not signed in. Sign out, sign in. Okay. Oh man. Okay. So, okay, let's start over. In Canvas, you can click on Cumulative Review Worksheet and then data sets for this worksheet's at this link. That will bring you here. You'll scroll down until you get to the Cumulative Review number 1. Click on StatCrunch. There we go. Sign in, and it'll have the data already built in for us for some of the cumulative review stuff that we're going to be doing a little later. Okay. All right. But we're not going to start with that. We're going to start with, back here in Canvas, we're going to start with the Chapter 4 project. Okay. So Chapter 4, Project 1, exploring the correlation coefficient. Okay. So we will work on that today. So click on that in Canvas, the Chapter 4, Project number 1. And there'll be a video that you can watch on how to do this assignment, but there's also a link right here. Open this Google document at this link, and that's going to bring you to the Chapter 4 project. Okay? All right. So here in the Chapter 4 project, we need to go to File, make a copy. right? I don't know why this is a 5. That's fine. Kids. Okay. And you're going to save it in a different folder. So you can save it under My Drive or uh, just anywhere that you've got it saved. Someone earlier this morning accidentally clicked on the X and closed theirs. Okay, so the nice thing about Google Documents is it saves, it automatically saves. You don't have to tell it to save, but you have to know where you put it. So if you accidentally close this and you need to get back to it or you need to study it for the midterm, make sure you put it in a folder where you can find it. Okay. All right, so now we can start working on our project. Okay. All right, so what we're going to do is we're going to access the applet in StatCrunch. So we're going to go to StatCrunch and we're going to select applets, correlation by eye, and then hit compute. Okay. So if you go to statcrunch.com and then you sign in, this orange button will light up and you'll click on that and then it'll bring you to a nice blank spreadsheet. You can also use the one that you opened previously that had, the data on here. So if you want to use that one, that's fine too. Just anyhow, what we're going to hover over is applets and then correlation by eye. Okay. So what this is it says guess the correlation using an interactive scatter plot. And you're not going to change any of this. You just hit compute. Okay. So what this is this is kind of a little game where you try to guess the correlation coefficient. Okay. So you can move these dots. If you click on the dots, you can move them around, right? So, but anyway, what you can do is up here where it says reset, you can reset that, clear that out. Okay. So let's look at our first question. Question number 1, create a scatter diagram of 12 to 15 observations with a moderate positive relationship. Okay. So on page 253 in your course pack, actually 250, not 253, 255 in your course pack. There's a yellow page in your course pack on page 255. Mine's not yellow, unfortunately. Mine's just boring white, but this is your exam notes packet, okay? And there's a really great number chart here, which talks about the correlation coefficient. This whole page here is chapter 4, okay? So we're going to be using this whole page all for pretty much everything in chapter 4. But basically, the correlation coefficient, when you're doing a least squares line, you have a bunch of dots, you have a bunch of a scatter plot of dots, and you have an x-axis and a y-axis. And you're basically seeing how those two different variables relate to one another. And the correlation coefficient comes out of the least squares calculation. Now, we're not going to actually do a least squares calculation by hand, but we are going to use the correlation coefficient. And the number you get for the correlation coefficient is somewhere between -1 and +1, okay? So if it's a strong positive relationship, you get a number between 0.8 and 1. If there's no relationship, you get a number between -0.3 and +0.3, okay? All right. Anyway, back over here. So what did we want? We want to create a scatter diagram, 12 to 15 observations with a moderate positive relationship. Okay. So a moderate positive relationship is somewhere between 0.5 and 0.8. So give me a number in that range, 0.5 to 0.8. Give me a number in that range.
0.6.
0.6, 0, and then 0.7. Yeah. So that's what we're going to be targeting as we build this thing. Okay. Awesome. All right. So here we are in StatCrunch. For sample size, I'm going to put in 12 to 15 dots. Okay. And you're going to hit simulate, and that'll give you 12 points. Okay. Now, you can imagine if I tried to draw a line through these are kind of scattered all over the place, okay? So I might want to move them into more of a line, okay? Not a perfect line, okay? But, close-ish, okay? So if I do this, this is probably too strong. This is, so down here we can play the game. I'm going to guess that this is 0.9, and we can check and see. Oh, no, actually, it's not. Okay. So let's click on show, and that's going to show us what the correlation actually is. Oh, why is it so low? Ah, that's why. I got a dot. I got one dot hanging out down here. I didn't see him. So let me move that over here in the line. Okay, so now all my dots line up. And so I get a correlation coefficient of 0.97. That's too high. I need something like 0.6, 0.7. Okay. Um, so uh so what you do here is Jacob, to get into this, you go to applet correlation by eye and then hit compute. And then it'll give you a whole bunch of dots. So you can reset that and do like 15 and then simulate, and it'll give you a bunch of dots. Okay. Um, okay. No, so on StatCrunch.com, you're going to click on this orange button here where it says Open StatCrunch. That's just going to bring you to a blank spreadsheet. Okay. All right. Okay, so these dots are too lined up. Okay. I need a moderate positive, so I need something that's closer to 0.5, 0.6. So I'm going to move these dots around, but I'm not going to make it a straight line this time. I'm going to kind of make it a little messy. All right, so what's my correlation now? Ah, there we go. That's better, 0.6. So it's not a perfectly straight line now, it's 0.7, okay? If I tried to draw a line through the middle of these dots, it would be like this, right? Okay. So click on show right here and it'll show you what your correlation coefficient is. Okay. If you want to play the game, you can. So, if I want to guess that this is 0.7, I can check and it says, yeah, you're within 0.1. You're within 10%. Okay. If my guess was 0.4, it says, nope, you got to try a stronger number, try a bigger number. Okay. That's not what we're doing right now. We can just hit show and that'll show us what the correlation coefficient is. So, okay, so this one works. I just need a correlation coefficient somewhere between 0.5 and 0.8. So this is good. I want to copy this graph into my project. So I'm going to go to my snipping tool and I'm going to grab this. Make sure you show the correlation coefficient. I want to see what it is. Okay. So I can see the 0.7 here. And we'll drop that into my project for question A right here. Okay. How did I do that? I went options. I could also, if I don't want to use my snipping tool, I can do options copy, and that'll pop this out, and you'll notice that the correlation coefficient is still showing. Okay. So I right click and copy that image and then paste that into my project. Okay. Question A. All right. Question B, move some of the observations around to make a weak positive relationship. Okay. So looking at page 255 in your course pack, what number would, for the correlation coefficient, would give me a weak positive relationship?
Like a 0.4.
Yeah, like a 0.4, yes. So you'll notice that weak is between 0.3 and 0.5. So 0.4 would be right in the middle. So that's what I'm targeting this time. Now, to make it a weak relationship, I need my dots to not be lined up so much. So I need to spread them out a bit. Throw one over there, throw one down there. Oh, I messed it up too much. 0.25. Oh my goodness. Let me move it a little bit back in line. There we go, 0.4. It doesn't have to be that close, okay? So any number between 0.3 and 0, so 0.38 is good, okay? Or 0.45, whatever, okay? Um, all right, cool. So now that I have that, I'll do another screenshot. We're going to be doing a lot of screenshots today, a lot of snipping, so make sure you got that snipping tool handy. All right, and I'll copy that, paste that over into my question B for the week one, right? All right. Question C, move some of the observations from the scatter diagram to make a strong positive relationship. All right. So what number would I be targeting there for strong positive? I need somewhere between 0.8 and 1. So thank you, Mark. 0.9 is good. That's what I want. So I've got this one over here, which is close to 0.9. So you'll notice that what I need to do, the difference between these numbers is this one, my dots are very lined up. This one, they're just kind of all over the place, right? So if I want a 0.9, you just got to put them in a line, right? It's easy enough. Making a strong positive one is actually the easiest. So there you go, 0.9. Nice. And you don't have to be in a perfect line. And actually, you're not going to want them in a perfect line because that'll be uh, a perfect relationship. We want strong, not perfect. So 0.97. Okay, so I'm gonna screenshot that guy. There we go. And that's question C. All right. Question D. If you align all the points into a straight line with a positive slope, what would be the value of the correlation coefficient?
1.
It would be exactly 1. Okay. Now, you don't need to do that because it's hard to do. You're not going to be able to do it with 15 points here. Okay. If I wanted to do it, and you don't need to, like I said, but I could do it with 3. If I hit simulate, I got 3 points here. Try to get them in a perfectly straight line. Let's hit show. Oh, I'm close. Dang it. Off by a little bit. There it is. So, um, even that's hard to do. So with 3 points, okay. So if you have 2 points, okay, it's guaranteed. Okay, at 2 points, your correlation coefficient is always going to be 1. The shortest distance between 2 points is a straight line, and so you'll never have anything other than 1 or negative. So, by the way, the slope of this line is positive. If I was to draw a line through here and walk left to right, I'd be going uphill, right? So this has a positive slope. If I was to switch this around and have my slope going down, my correlation coefficient is negative. Okay. That doesn't mean it's bad on that. And actually, this is actually still a really good, strong correlation. It's just that it's in the negative direction. So the correlation coefficient, the sign on it just tells you the slope, okay, whether it's positive or negative, okay. Okay, let's go back to our project and let's move on. So part 2, negative association. So hit reset at the top, and then we're going to do it again, create a scatter diagram of 12 to 15 observations with a moderate negative relationship. Okay, so I'm going to hit reset. Okay, on this guy, I don't need this one. Let's put in 15 points here. Hit simulate. All right, so if I had to draw a line through the middle of these, it would probably be a line like this. So this is a positive relationship. It's not that good, so it's probably like a 0.4. I'm gonna guess 0.4. Oh no, I was 0.7. Oh, that's way better, higher than I thought it was. Okay. But that's positive. I need a negative. So I need something in the negative 0.8 to negative 0.5 range. Okay. So I'm going to take all my points and move them around until I get my number, my slope going downward. All right. That looks good. So now you can see if I drew a line through the middle of these, it would be like this, okay? So I have a correlation coefficient of negative 0.6, negative 0.7, somewhere around there, okay? All right, let's copy this. So you can go to Options, Copy, and then right-click and copy that image, or you can use your snipping tool, paste that into StatCrunch. And remember, I want to be able to see that correlation coefficient. So, all right. Move some of the observations around to make a weak negative relationship. So I still need it to be negative, but I need zero. What do I need? What number do I need here now? Give me a number between negative 0.5 and negative 0.3.
Negative 0.4.
Mm-hmm. Yep. Thank you, Ivana. So I will mess these up a little, try to spread them out, make it less of a straight line. There we go. It's negative 0.41. Okay. All right. Move some of the observations from the scatter diagram to make a strong negative relationship. Okay, well, for that, we need like negative 0.9. So we just need them in a straight line, right? So we can do that. That'd be a perfect straight line. Go. Negative 9.4. By the way, it doesn't have to be a 45-degree angle, right? So it doesn't have to go like this, okay, for it to be a strong positive. So this is a like a still a negative slope and it's still a strong correlation. Okay. All right. So Nina was asking, so when we were looking at a moderate one up here, when we were making a moderate one, we needed a number in the range of negative 0.8 to negative 0.5. So that means you can't have negative 0.4, negative 0.3. That's a weak negative relationship. So Nina, you're going to need to make them a little bit more in line. You need a number that's between negative 0.8 and negative 0.5. All right. If you align all the points into a straight line that has a negative slope, what will the correlation coefficient be?
-1.
-1. Yep, you got it. Okay. Part 3, no association. Create a scatter. So let's hit reset again. Create a scatter diagram of 12 to 15 observations with no relationship. Okay. So no relationship would be this no linear relationship right here. So between negative 0.3 and 0.3. So 0 is right there. So we want to be as close to 0 as we can. Okay. And So let's reset this. Let's do 12 to 15 points. So I'm going to do 13, hit simulate. So right now, if I drew a line through the middle of these, it'd be like this. This is probably like a 0.6, 0. I'm going to guess 0.7. Ah, I got it. It's 0.76, okay? But I don't want that. I want my numbers to just be all over the place. So I'm going to move my dots, move some of my dots up here, some of my dots down here, just kind of make a mess, okay? Look at this mess, okay? So my correlation at the moment is 0.59, right? 0.1. So that is no relationship. If I tried to draw a line through the middle of these, I mean, you could draw a line like this, you could draw a line like this, you could draw a line like this, like they're just kind of a mess. So there we go. Okay. Why do we care about this kind of stuff, right? We're messing around playing this game, right? But like whenever I'm teaching class, like I try to relate it to real world situations and I try to relate it to, my my work that I've done in the past. So, if I have two data sets, I have an X axis and a Y axis. I can plot those on a scatter plot and we can try to find like a relationship that can help us predict things. Okay. Like for example, maybe my x-axis is your income and the y-axis is uh, your life expectancy. Um, in general, like it's not a perfect correlation. That's probably a moderate positive relationship where if you make more money, in general, your life expectancy is a little higher. Okay. So if I know how much I'm making right now, I can kind of predict how long my life expectancy is. Okay. Obviously, there's going to be outliers, like someone gets hit by a bus or whatever. So things aren't necessarily in a perfect line. Okay. But it allows us to make predictions. Okay. On the other hand, if I was looking at like how much money I make compared to how much my housing costs are, that's probably a strong correlation, right? So if I make more money, I'm probably living in a nicer house, right? And vice versa. That's kind of a understandable guess. So again, you can make predictions based on uh, that relationship. What we're doing now is we're looking at no relationship. Okay. So, for example, if I have my X values here, if this was like, uh, I don't know, let's say this was how many hours I sleep each night, and the Y axis is how many times I go skiing each year. Those are kind of just, those aren't really related, right? I mean, maybe you can assume that the insomniacs they ski all the time. No, right? There's not really a relationship there. Okay. Or at the very least, if there is, it's not really a causation. We'll talk about that correlation is not causation. Okay. But those two like are going to be kind of like scattered all over. Okay. Um, okay, so let's go to the next one. J, create a scatter diagram in a U-shaped pattern. Okay. So I'll come over here and uh, I might just reset this. So we'll do 14 points and simulate. Okay, so I'm going to make this into a nice U-shaped pattern. So we'll go like this and like this. That swoops up. That. Okay, so there's my U shape. Uh, what do you think if my guess would be? So is this a strong correlation, weak correlation? Without actually showing yet?
It should be weak because it's not linear.
Yeah, it's not a straight line, right? So I have if I had just this part of the graph, that's going down, this part of the graph's going up. So if I guess like 0.4, or no, yeah, 0.4. No, that's too high. This is a terrible relationship or terrible correlation coefficient, 0.0054. So that's telling me that it's in this range. Now, that's not saying that there's no relationship. It's saying there's no linear relationship. Okay. So let's copy this one though. Let's grab our snip of this. Put that in here. Okay. Um, so part K, what does a correlation coefficient close to zero suggest? Um, so this one is close to zero and it's just kind of scattered all over the place. This one has a pattern, but its correlation coefficient is still close to zero. Okay. So just because it's close to zero doesn't mean there isn't a relationship between the variables. It means it's not linear. Okay. So uh, no linear relationship. Okay. And the reason why that's important to specify is because there are lots of different relationships that can happen between variables. Okay. So you might have some shape like this, okay, um, where or maybe it's the other way around, where you actually can compute and a formula for X and Y that's actually a very good predictor. Okay. It's just that you can't do it using the least squares regression because least squares regression gives you a linear relationship. And linear is the most common regression that we will deal with. And it's the only one we'll deal with in this class. But just be aware that there are other types of regressions. I mentioned my aerodynamics of baseball project I did. And during that, uh, we had to do a regression that was a sine wave superimposed on a parabola in order because the relationship there was definitely not linear. It went up and down because the ball was spinning, so it was going up and down and up and down. So, anyway, so next is part four. Is the correlation coefficient resistant? Okay. So let's reset this again. Okay. In the lower left corner of the applet, draw a scatter diagram of 12 to 15 observations with a correlation coefficient around 0.8. Okay, we can do that. So let's go back. Let's reset this guy. Let's do 12 to 15 points. Let's hit simulate. And what are we at right now? Oh, we're at negative. So I need this to be positive 0.8. So they kind of got to be in a little bit of a line. Not perfect, right? This is going to be a moderate positive relationship. Okay, there we go. That's close enough. Okay. So my correlation 0.8. So I'm going to grab a screen snip of this 0.8 and I'm going to stick it right here. Okay. All right. Add another point in the upper right corner that roughly lines up with the other points. And then put another picture. Okay. So we want a new point. So to do that, in StatCrunch, you hit add point, and it's going to ask where you want that point. So this is the X value, this is the Y value, so it's going to be something comma something. So let's put it right here at like 15 comma 15. 15 comma 15. Okay, so it put that one right here. I'm going to put my dot on it or my cursor on it. Okay. And it actually made my correlation stronger because that is kind of lined up with the other dots that I have. Okay. So I'm going to grab a screenshot of this. So now I had 13 points. Now I've got 14 points. Paste that. All right. Move the additional point around the scatter diagram and note how the correlation coefficient changes. Okay, explain why the correlation coefficient is not a resistant measure. So by resistant, we mean is it resistant to outliers or skewing, right? We've talked about that before, that standard deviation and mean are very affected by outliers and skewing. They are not resistant to outliers. If you have a skewed data set, you should use median or interquartile range for the center or the spread, right? Because those are very resistant. So let's find out if this correlation coefficient is resistant to outliers. Uh, so right here's my correlation coefficient. Here's my 15, 15 I put in there. So I'm going to grab that. I'm just going to kind of move it around. So if I moved it over here, my correlation is now 0.5. So that went from a strong positive relationship. Now it's a moderate. If I put it down here, now it's a 0.3. Now it's a weak uh, a weak positive relationship. So uh, just moving that 1 point can totally ruin your least squares regression, can totally mess up your correlation coefficient. So yeah, the least squares regression is like your mean and your standard deviation, is not resistant to outliers. It gets messed up easily by outliers, okay? All right, so uh, explain why the correlation. So the correlation, I can't spell. Outliers. All right, so the correlation coefficient is not resistant to outliers since moving just a single observation, so just moving a single dot will drastically change the value of that coefficient, okay, that correlation. So um, yeah, so how do we handle that, right? Like if we were dealing with real data and we wanted to you know, create some kind of prediction, right? I mentioned earlier, maybe you want to look at like a person's income and you want to figure out what their lifespan is, their life expectancy is. Well, you might have some outliers there where you might have someone who doesn't make a lot of money, but they live to be 100 years old. And you might have another outlier in the other direction. You might have someone who's super rich and they get hit by a bus and they die young. So how do you deal with those outliers? There's a couple different ways. You can, there are formulas that will allow you to smooth that out using like a normal curve. There's lots of different ways. We're not going to get into those. You could just throw the outliers out or do it, a different way to measure it. So anyway, that's fine. We're not going to worry too much about that for our class. That's it. That's the project. So let's make sure we submit this. You go in the upper right hand corner and click on share and make sure we change our access to anyone with the link. And with copy link, it says link copied. So I can come over here to Canvas, scroll down, web URL, and I can paste my link and then submit assignment. We get our confetti. All right. Nice. All right. So that is our chapter 4 project today. We also are going to work on the the cumulative review worksheet number 1, which covers chapters 1 through 4. We'll do some more cumulative review worksheets as we get ready for the midterm. Okay, so these are going to be helpful for studying. So on page 412 in your course back. Page 412 in your course back. Okay. Now we're not going to do the entire worksheet today. It is not due on Tuesday. It's due on Thursday, but we are going to start it today and we'll finish it next week. Okay. Okay. So page 412. Yes. Okay. Um, And just like our other worksheets, we're not going to go through the entire worksheet yet. I'm going to start with giving you some hints, and then we'll stop the recording and we'll go through and finish everything. So these hints, by the way, this is to help you be able to study for the midterm. So, if you just write down the answer that I give you tonight, okay, good job, you get 100% on the worksheet. But when you're studying for it, you're going to look at this and be like, how did we calculate that? I don't remember. So that's one of the reasons why I give you the hints, okay? Okay, so we have this one. The following graph shows the incarceration rates for all the countries and territories in the world, okay? What type of graph is this? What kind of graph is this, guys?
Frequency histogram.
Yep. It is a histogram because you'll notice that I've got all my bars are right up next to each other. We know that it's a frequency histogram because each of the bars is a count. We're measuring whole numbers, okay? So we're counting, we have 24 countries that have an incarceration rate between 0 and 49, okay? Um, a relative frequency histogram, we would not be looking at whole numbers, we'd be measuring percents or proportions. So this would be like 0.6, okay, or whatever. By the way, a frequency polygon would be where you take the middle of each of these bars and you connect them up like this, and then make some kind of weird line shape, okay? Um, okay. Uh, what is n? So if n, you just add them up. Okay. Part F's the one I want to talk about, though. The U.S. Is in the 99th percentile for incarceration rates of countries worldwide. Interpret what this means in the context of the situation. So when we say interpret, we're looking for an English sentence, and you can find on page 253 at the bottom, there is a script on how to interpret a percentile. Okay, so the 99th percentile. So K in this case would be 99. Okay. All right. On the next page, page 413, um, we have a frequency distribution, and we've seen these before, right? Um, and for the frequency distribution, we don't have a project that goes with this one, so really I just need to fill the numbers in, okay? But for this frequency distribution, there is a Google Sheet for us. So back over here in Canvas, if you click on the cumulative review worksheet, there's a link that'll bring you to uh, it'll bring you to that long list of other links for all the worksheets. This one, and the cumulative review right here, the Google Sheet, this one right here. This Google Sheet will open up this, okay? And this is the data for um, this frequency distribution. So you can just fill this in here, okay? So once you've got all those numbers filled in, We can go through and answer these other questions. Um, this one here, find the mean and the standard deviation for this frequency distribution. That you'll find on page 254. And there's three methods that we talk about for calculating mean and standard deviation, depending on whether you have the raw data, that's method one, whether you have a frequency distribution, that's what we have here, so that's method two, so we'll be using method two. And method three is if you have a probability distribution, which we haven't even got to that yet, so we'll get to that later. Okay. On page 414, following data shows the average age at marriage for men in a random sample of states. We're asked to find the mean, standard deviation, a whole bunch of other numbers, the variance, okay? So this is page 254, and this one is going to be method one, because this is the raw data. Raw data is just collection of numbers. I have a column of numbers, okay? Where frequency distribution, I have the frequencies and I also have the midpoints. I have two columns of numbers, okay? So, so you'll do that one. And then we talked about fences already. Interpret P50, the 50th percentile. And even though the 50th percentile is also the median, you can use that same script on page 253 at the bottom for the 50th percentile, okay? In Utah, the average age at first marriage for men is 26.4 years old. What is Utah's Z-score? So page 253, the formula for a Z-score is whatever that number is. So you take that number, you subtract the mean, you divide by standard deviation, okay? There's parentheses around it if you plan on putting that into decimals or into your calculator. So, but what you're doing is you are measuring the mean, which is in the middle of your data, and you're subtracting to tell how far away this observation, this number is away from that mean. How many standard deviations away is it? Okay. And then we're asking, is it unusual? So unusual is also on page 253. And there's two different bullet points here, depending on whether you have a z-score or a probability. Okay. For a probability, any value that is less than 5% probability is unusual, okay? Those are rare events. Now, z-score is any score beyond two standard deviations away from the mean. That's considered unusual. So on your normal curve, this right here is the z-axis. If you're very close to the mean, then it's not considered unusual. This is two standard deviations right here, and that's why the 5% and the 2 go together. Approximately 95% of the data lies within two standard deviations of the mean, okay? So that means that 5% of the data is outside two standard deviations, okay? So when you're checking if something is unusual, it's important to pay attention to whether you have a z-value, but every single z-value also has a corresponding probability with it. So are you looking at probabilities or are you looking at z-scores, z-values? Okay, so pay attention to that. Okay, I know I'm saying this over and over, but you know this is something that people have struggled with. Okay, so okay, on page 415. The wheelbase of all cars built in 2019 was normally distributed with mu, that's our mean, okay, 110, and this is sigma, which is the standard deviation, okay, 7.3, okay. So draw a reasonable picture of the distribution. So Your middle is the mean right here. So what's our mean? Our mean was 110.2. Okay. And then if you go one standard deviation away from that, so if you add 7.3, that puts you there. And if you subtract 7.3, that puts you here. And this is 34%, and this is 34%. Okay. So make sure you're drawing all the lines there, all the values on the x-axis, z-axis, sorry, same thing, and all the probabilities in there. Okay. All right. Yeah, this is page 253. Okay. Um, I think that's probably good. Um, yeah, I think that's good. So, uh, let's so let's start working on our worksheet. Okay.